Alrighty, welcome to the learning curve. This is going to be a tech talk with Scale AI, talking about technical integrations with Zenseact. So let me start off with a quick couple of housekeeping notes here. So first of all, this is being recorded, and because you are here and you signed up, you will be given the recording after this. So frantic note taking is optional, but you will have the recording afterwards. Throughout this conversation, there's going to be a Q&A portion at the end, and you're welcome to go ahead and add Q&A questions as they come up or as you think about them. You can do so in the Zoom application. There'll be a button for Q&A there at the bottom. Also, after this webinar, you will be getting a quick survey. We'd love to get your thoughts on how it went, what was most helpful, and any other feedback that you have. So first things first, I'll go ahead and introduce myself, and I'm very happy to have Bolin here with us. So my name is Shaun. I lead Scale's field engineering team. I've been at Scale about a year and a half, and field engineering at Scale means we do all the post-sales technical things. And so technical integrations is certainly one of those things. We do our docs and our SDKs and APIs and all that good stuff. So we know lots about integrations, and Bolin does too. So Bolin, I'll go ahead and let you introduce yourself.
Yes. Hi, Shaun. Very nice to be here today with you. And hi, everyone. My name is Bolin Shao. I'm the product owner in Zenseact. And essentially, I'm the one who's responsible for getting the data for deep learning, in short.
All righty. Thank you, Bolin. So at this point, I think we can probably go ahead and pause our slides. And really, we wanted to kind of make this a pretty conversational chat just about your technical integration so far, Bolin, and what you've been building over the past couple of years with us. So first things first, I want to make sure the audience has a good understanding of what Zenziac does. Can you tell us a bit more about what your team does day to day and kind of what your goals are?
Yeah, sure. Maybe just a quick intro for what Zenseact does. So Zenseact is basically a software company, and our purpose is really to protect life on the road by developing a complete software stack for AD and ADAS applications, from sensing to actuations. And our current focus is to build a cutting-edge software mobility platform in order to serve various levels of autonomies and offer unequaled scalability at the same time. And of course, in this complex software stack, there are many algorithms, and deep learning is definitely playing a rather crucial role here. And the main responsibility of my team here is really to enable deep learning in Zenseact by transforming data from its raw status to a, say, processed and enriched status so that they can be consumed by deep learning algorithms. Yeah, that would be a short intro to what I do and what my team does.
Super helpful. Thank you for that. And so kind of just taking that maybe one step deeper here, as we think about how you kind of do these data transformations and make sure you can get the data that you need, how does kind of, data go from, say, car to model today at a high level?
Yeah, I mean, of course, for us to develop such a software stack, it really involves using a lot of data. It's a data-driven development and validation, of course. So I would say the data flow starts from really two manual steps that is hardly to be, replaced by automations. So the first step is really to collect the data all over the world in our test vehicles by our test drivers. Well, you need to be there to physically drive the car. And the second step is, well, after driving, that you need to physically ingesting the hard drives that contains the data to our data center. So those are really the two first and manual steps. And basically after that, it's a series of automated processings, including you need to indexing the data, classifying them, filtering, cleansing them by different purpose and by different quality of the data. And of course, you will need to enriching the data with all sorts of metadata on different levels. And for deep learning specifically, we will also need to continue to do the curation step. And for supervised learning, acquiring the ground truth is rather important as well. That's the next step. And finally, with all the required information we have, we basically pack everything that a deep learning training session will need into one package, and then just start our training iterations.
Got it. Yeah, no, that's super helpful to kind of get a high level understanding of, just how is data actually kind of transformed all the way through there. As we think about kind of where Scale is helping and parts of that process, can you just tell us about kind of how Scale sits in your current stack today? Where do we kind of help you out specifically from your perspective?
Yeah, I mean, along this whole really long, say, data pipeline, Scale is at the part where we acquire ground truths from. So Scale provides us with manual annotated ground truths to train our neural networks.
Got it. Yeah. Nice. Okay. Well, perfect. I think now that we kind of have this base, I'd love to get into a bit more of the integrations themselves. So first things first, there's certainly different levels of effort you can kind of put into building a data integration or kind of, these pipelines with us. A lot of folks are saying, hey, why can't I just go email you the data? I'm going to go put it, somewhere like this. I'm going to email you a CSV file of links. I just need the annotations back. You've put a lot of time into it at this point. Why did you kind of start prioritizing the time and effort needed to go like build this robust data pipeline with us, as opposed to maybe just keeping it, sending the CSVs of files back and forth, that kind of thing?
Yeah, of course. I mean, to be honest, we started with that, just like you described. So when we started our journeys in Zenseact, and we basically really started with smaller projects, annotations, couple thousand images. So for those really smaller proof of concept projects, I would say a more manual process, it might work, and it might even be preferable. It's more flexible. So you can choose on every steps, and you can tweak and change it as you go. But really, when we are scaling up, I mean, for this kind of volumes at this industrial scale, I would say, it's really hard to do so. It's almost impossible. When we are talking about like tens of millions of annotations. I mean, a simple example is if you try to understand, the status of every single image you have in the pipelines. I mean, just to know that if it's been annotated on what project, annotated with what informations, that itself just requires quite a lot of work with manual process. So I would say the project management overhead for a manual process would be just simply too large to handle without automations and integrations. And essentially, I would say it's a trade-off between long-term manual overhead and the short-term engineering work, and also a preference of stability and predictability over flexibility.
Yeah. Yeah, I could see where kind of getting a more stable, predictable pipeline becomes more and more relevant. Was there a point for you, Bolin, where it kind of said like there's a moment where it's like, yeah, this manual approach is no longer working, and you just kind of have like this moment like, okay, I need to make a change here. We need to do it a little bit differently because otherwise this is pretty painful for the team internally or something like this?
Yeah, of course. I would say that's not just one moment. It's probably a series of moments that leads to us.
Okay.
I mean, we made mistakes, of course, along the road. And I mean, simple stuff. We downloaded our annotations through emails, through CSV files, and we converted them into an internal format. We stored them somewhere, and then seems like we forgot. So yeah, that happens all the time. I mean, we're humans, and human makes errors. So we're thinking, yeah, it's time to step away from the manual process to be more automated and machine assisted management. So yeah.
Yeah. No, we are all humans. I think that's always a good reminder, right? Despite our best intentions, sometimes we need a bit of help for ourselves too, for sure. So
yeah.
As you're kind of building out your data labeling workflow, I'd be curious, kind of, what did you actually prioritize first? And then maybe a follow on, knowing what we know now, kind of, what would you have prioritized earlier than maybe you did as we kind of built out the integration?
Yeah, I mean, so when we started with our first integration automation pipeline is actually replace the last step of this annotation pipeline. To retrieve the annotations, we built a callback servers and together with Scale, and we simplified that retrieving annotation step to, from manual downloadings to automatic. So that is really the first step, and it was really a good start. I mean, give us a good taste how this automated workflow could look like and how much manual effort it can save, and we can, shift our focus to other parts. But I would say now looking back, this was definitely still going to be, I would say, a good starting point. It's not so complex to build, and Scale has really good support on this part. So that still would be our priority. But I would say I would also try to prioritize monitoring the status of annotations. I mean, our data is in the pipelines. I mean, knowing what is the issue and what the bottleneck is, it's going to really help us, both us and I would say our partners like Scale, like you.
Yeah, so kind of investing in building out different dashboards or kind of other monitoring solutions there that help, I suppose, just understand the state of, you talked about earlier, is this data even labeled or not yet? One, and then maybe it's some parts around like the data quality or other pieces there, that kind of thing. So
Yeah, exactly.
okay, very cool. Kind of doubling down on this pattern of kind of lessons learned. Any other kind of lessons that you would, you've kind of learned over the past couple of years of trying to go scale out these efforts and do more deep learning product solutions? Yeah.
Yeah, of course. I mean, I would say since the first point is since we collect our own data, we build our own vehicles to develop this whole software stack. A lot of things are custom made, and with that meaning a lot of things can go wrong. And when things go scale, basically means can go wrong means will go wrong. So I would say ensuring data quality is rather important. I mean, in the early days, I think we even had cases where we send you the data, but then the annotators couldn't actually do the work because the data we sent was corrupted in some sense, missing a sensors, calibration is wrong. So yeah, I would definitely prioritize the data qualities. So that is one big crucial point. I would say
And I
another
suppose
point.
that's kind of data quality though on both sides, right? There's like making sure the data we have is actually useful to you and labelable. And then also there's probably the annotation quality side coming out of it to the other side as well. And probably both are very important, I imagine.
Yeah, of course, definitely. So this data quality is at really both sides. And I would say process-wise, if we want to, make this good data quality, so I would say another part is really to have a, a shorter feedback loop. I mean, this not only refers to the actual annotations, but actually the entire data pipelines. I mean, basically, when you have like petabytes of data coming in every week, with tens of thousands of annotations required every week. I mean, if your feedback is late for 1 week or a improvement that is delayed, then that will lead to results in metadata to be useless, and often that results in extra cost for rework as well.
Sure enough, right? So if you're paying for all this data to be labeled, you want to make sure it's useful and going to be coming at the end in a way that's consumable and able to be used for sure. So
Exactly.
um, that makes sense. I'd like to kind of switch gears a little bit. When you think about the benefits you are seeing now as a result of your more integrated labeling workflow, does anything kind of come to mind just in terms of some of the key benefits of having all this integration work done and kind of in place?
Yeah, I mean, I would say the first point in that point is what we touched a little bit just now. So it's about human errors. I mean, when there's human interactions in the pipelines, then of course it's going to be human errors. I mean, file is missing, you have a wrong format, and so on. I mean, if we have a automated workflows and with tight integration on both ends, basically this type of errors can be reduced to zero, and that is, I would say, quite an improvement. I would say another point is to to have the speed. We aim to replace human interactions in the pipelines by automated process really as much as we can.
Sure.
So without the dev teams doing manual works to prepare the data, to send the data, and manually downloading the data and inspecting the annotations, with all these steps, I mean, really dramatically speeds up our workflows and increase our volumes throughput as well. That's quite important as well, really at scale.
I think for us too, I always see my job as automating myself out of the job. And you never
Yeah,
really automate yourself out of the job. You just get to do cooler and cooler things with the same engineers that you already have, right? You do the
exactly.
boring stuff and automate that part. Then you can do the cooler stuff later on. So
Yeah, exactly. That is definitely the case.
yeah.
With more, I would say, integration works, the data qualities can also actually be improved. I mean, that's really with the cool work we have done together. With really opens up more possibilities. And for us to be involved in the loop, not only just a traditional sense. We send you some data, we order adaptations, and we wait and for a big delivery of everything. I mean, that kind of delivery is really normally really leads to some sort of rework and annotations. But now with this API integrations we had together, yeah, we have this fast track in our workflows. Your annotators can ping our servers for quality checks before he or she can conclude the annotations. So we know that the annotations sent to our callback servers are generally of good qualities. So really, this is something else we haven't really thought about when we started journey, but it really turns out along the way. really appreciate we have this.
Yeah, and to maybe clarify kind of what that is for the broader audience here, we have a feature, I'd say it's in beta right now, where we are able to take pretty much the work as it's being labeled and go ahead and ping Zenziac's server and say, is this current state of the work valid or not, depending on a set of rules that Zenziac has developed. And they don't catch everything, but they allow for certain states of polygons, for example, to make sure that those states are going to not be in how it was drawn. And as opposed to trying to catch those errors only after the task was submitted back to the Zenziac folks to go download, we can catch those as they are happening live in the labeling workflow. And we were excited that this could also speed up our process quite a bit as well there. So that's kind of what this, we're calling this a real-time validation feature here. And we're very excited about that one. So, and Bolin, I'm glad it's working out for us. I think I'm happy with our results as well. So, and kind of on the note of kind of seeing, more success, how do you kind of start measuring the success of your data pipeline? How do you know it's working or like, this is time well spent? Any kind of anecdotes around that?
Yeah, I mean, I would say, of course, there's a lot of aspects to, to evaluate how good your data labeling pipeline is. I mean, of course, the final point is how valuable the outcome is to basically to consumers, to your end users. But then I would say, if I were to choose one measurement to evaluate our data pipelines, I would really choose speed. It's not really the speed of getting annotations; it's the speed of having this development feedback loop. So it makes it really quicker and easier to spot issues. And maybe we have a misunderstanding of annotation guidelines. Maybe we have a different use case for the end annotations. And maybe they have a wrong sensor configurations. I mean, it's a shorter development feedback loop. I mean, everything can be captured. And it's really about, you are taking baby steps, but as many as you can, as fast as you can. It's essentially being agile is the way.
I think that's actually a really interesting point you're making, right? It's not, we need lots of annotations at the end of the day just to do kind of our modeling work, but more important is just getting the feedback in place and being able to kind of course correct or make sure that everything is kind of working as intended, and that the short feedback loop even allows us to discover new use cases inside of like, hey, I got the first set of data back and I just realized we totally forgot about X. I need to go add X in there before we go do the next 20,000 images, that kind of thing, and pay for all that work too. Yeah, I think that's a really good point. Very cool. I wanted to ask you, we talk about quality quite a bit now at this point. What tactics has your team been using to kind of drive higher quality in the existing pipelines themselves?
Yeah, I mean, obviously the quality here refers to probably not only just the annotation qualities here, but also the general data qualities we have. Yeah. I would say, of course, I would say maybe a little bit surprising to us and maybe to some of the audience here as well. I would say a good tactics here is really automation. I mean, it gets really, two parts. I mean, the first part is you remove the human errors, and the second part is kind of related to what we just talked about. Speed the process up and it makes it easier and faster to spot issues. I mean, it's almost impossible to just think that you can eliminate all possible errors in your data, and you have a top-notch data qualities. Sure. So really, the focus is to make it easier to spot and fix things. So, and automation is the way to go there.
That is an interesting insight, right? It's not just spending hours and hours and hours having a human go audit every single task. It's like, how do you find the bigger patterns and the trends overall in the data that allow you to make sure that, at large, the most prevalent data quality issues are going to be resolved. And ideally that kind of drives the right behavior and the overall kind of state of the quality.
That is correct.
Yeah, okay. I wanted to kind of ask you about any surprising tactics that we've kind of been able to leverage here. We kind of touched on it a little bit, but maybe I'll double down on this point as well. One thing that really was kind of surprising to me was kind of setting up dashboards showing the current state of all the data labels and any kind of, as you automated the error collection, that reporting, making sure that we had kind of shared dashboards to kind of look at those errors and make sure that we could kind of prioritize and resolve and kind of take in your feedback there. To me, I think that was really kind of a a pivotal shift, I suppose, in kind of how we were working together was having those dashboards that we look at every week, as we met and saying, okay, what are the biggest issues now, and what are the numbers themselves just saying? Anything that you wanted to add on to, or like other tactics that you've kind of developed on your side?
Yeah, I would say the dashboard that is a really surprising thing to us as well. I mean, we have our internal dashboard showing our data flow, where the data is, and at which status and at which steps. I mean, showing this kind of status is really makes it much clearer, to identify the issues and setting up your priorities. You should know what you should focus on in the next week, for instance. I mean, yeah, that is really something we should, emphasize, as well as how to solve these issues. I mean, some of the issues that you cannot really solve by yourself, maybe that was delivered to you at this way, or maybe that is from the supplier side. So you should really try to follow up with the issues. And I would say the few human factors left in this data pipelines that does require great attentions, and you should really making sure that those parts are being addressed properly. So that is surprising to us as well.
Yeah, it has been cool. I think just having a clear state of the world whenever you need it is definitely helpful to kind of drive clarity and what's most important there. I want to shift gears a little bit here. Has there been different types or different kinds of model work or ML themes that you've been able to do now as a result of Scale's data pipelines that were really hard or just not possible kind of before you kind of started working with the Scale team?
Yeah, I would say we started our collaborations a couple of years back, and when this whole ADAS and AED field was just starting to get popular, I would say. I mean, and then I would say most of our annotation attempts or machine learning stuffs are 2D image levels, and together with Scale, I would say our especially the 3D 2D linking annotation support. I mean, right now, basically all of our image annotations have 3D informations in them. So that is super cool. I mean, we enable 3D, 3D abilities in through our software stack with neural networks. And yeah, I would say another point I was just wanted to highlight here. I know Scale really did cool work with us to help us enable our multitask training. And Scale really developed this customized annotation support, for us to identify the relationship between a polygon and the polygon in the image. So that is really cool as a customized supporting work to us.
Yeah, so instead of trying to do a job to kind of annotate lines and one to annotate polygons, now we get both in the same image at the same time, and that allows for a lot deeper understanding and just frankly probably higher quality, right? Where we don't have disconnected lines and polygons hanging out there. They're all just there and they can be seen as a collective image or a scene in that way. That makes sense. And also, I guess on the 3D and 2D linking side, you're kind of taking maybe some of the insight, the 3D scene, such as maybe how far away something is from the vehicle or something like this, and able to kind of factor that into your model or the kind of the 2D metadata and context. Is that kind of how that's working today? Or are you able to share a bit more about kind of how that 3D, 2D linking is being used?
Yeah, sure. I mean, I would say right now we are mainly doing our specialized data actions and development work on camera images. And of course, those camera images itself, it's a 2D image, but we still, of course, predict 3D informations like the depth of the vehicles, the size of the vehicles, and even down to detailed parts with the pixel depth map. Maybe all of these things requires 3D informations, and for the most important parts for the vehicles, and then you do need the distance to the vehicles. I know that most recently Tesla has basically switched to a camera only approach, but for that approach to work, you really need 3D ground truth to know that distance to vehicles, and that has been super helpful, grabbing the information from the 3D space back to the 2D space.
Very cool. Thanks for telling us a bit more about that. I wanted to ask, we've done some cool work together. Where would you like to see more of a direction for us or kind of partners in this space to go to, right? I know there's lots of folks in this space, from your perspective, kind of the end user and practitioner here, are there any themes that you're saying this would be really cool or unlock some more use cases for us if Scale or people in general could kind of think about the problem in this way?
Yeah, I would say 2 points that we think that can be further developed in this space in general. I mean, the first part is about automated annotations. So we would definitely like to see more practical ways of doing that. I mean, our current understandings and say attempts in these automatic annotations is say one, the annotation accuracy requirement is really high. So like then the automation methods, regardless what it is, maybe a machine learning, let's say state ones, then those are not actually helping too much or at all. I mean, it seems like the annotators are going to spend more time in correcting them than to say starting annotation from scratch. So yeah, I mean, this is more of a, you probably need a new method and a new workflow to, work really well together. So that is something we'd like to see if we can find such things, in the market in the future.
Yep, got it.
Yeah, another point, if we say zooming out a little bit from this annotation work to the entire, say, data pipeline, we'd really love to see more interactions and integrations. I mean, with more parts of this data chain. I mean, for instance, it's like we just discussed, it's not really trivial to have a huge data set with zero quality issues.
Sure.
So we really love to see how that part can be assisted by our partners like Scale. I mean, of course, you guys have been informing us with severe quality issues like we just discussed earlier. When we send the data cannot really be annotated. And yeah, I mean, if that ability can be extended to more data, even say to uncurated data, then that would be really interesting for us, as a crucial step to ensure our data quality.
Yeah, so I imagine that maybe takes two forms. One is as you send us data, or maybe there's a kind of a pre-check that says, is this data non-corrupted? Is it labelable and valuable? And is the point cloud looking reasonable? Does the camera match roughly to the different things, or have everything kind of set correctly? So I mean that's one piece. And then also just what data do we, of all the data we've collected so far, what actually is most valuable to be collected or to be annotated more? And where's my valuable data kind of sitting on that side? Did I get that about right?
Yeah.
Yeah, I think we agree. We actually have solutions I think on both sides we're developing here. One is that we do have kind of abilities to kind of categorize data at large, kind of before it gets actually annotated. And then we're really excited about our Nucleus product to kind of help out on the curation of unlabeled data before it gets labeled, trying to figure out what's in data sets, how things are kind of roughly looking, and then making sure that you can select the most valuable data to be annotated later on. So we're early on those journeys, but maybe it makes sense kind of later down the line to explore those together. And if anybody else is listening, and if that sounds kind of cool, we'd love to chat more. Terrific.
That's good. Looking forward.
Yeah, me too. I think it could be actually quite useful given the context we've talked about today so far. Can you look at the future here? How do you kind of see this idea of like ML ops kind of changing over the next couple of years? And any kind of general themes or patterns that you're kind of expecting to see in this space at large?
Yeah, I mean, from my perspective, it seems like ML ops have really taken up the steps in recent years. It's been already applied to many places with this huge, I would say, potential of this machine learning, especially deep learning here, and the already big adoption in many areas. I would expect to see the MLOps really becoming more, standard and coming to larger scales and the traditional industries. And if, for instance, if MLOps can really support to adaptation to different, let's say, ISO standards and support for more validation work in, say, safety critical areas. For instance, here we're developing self-driving cars. That would be fantastic. I mean, one hard issues for using any statistic models of, say, in the self-driving areas, you really need to know that your product is safe. But verifying a statistical model is difficult, it's hard, and it's costly. So if we have some sort of standard ML ops workflows into that, I think that would simplify a lot of work for a lot of people.
Yeah, I imagine having different standards makes it a lot easier for you to know kind of where the bar is, and it's less about everybody trying to go validate statistically that their model is now sufficient. There is a standard here that we, is a trusted one that says this is now safe in critical areas. Very cool. I wanted to kind of end our conversation here just on a note of if someone today is kind of getting started on data labeling workflows and integrations with the partner kind of like Scale or anyone. is there kind of any specific wisdom that you want to share with these folks just as they were kind of getting started on this journey?
Yeah, I think that's kind of, we touched on that a little bit back as well. So
Okay.
if I were to reprioritize or start again, what would be the first thing I would prioritize to work? And that would be, I would say, a really easy to follow and dashboard showing the status or the things you want to have. It's a simple thing, and it's not so difficult to start with, but it actually provides much more value than one believes.
I think sometimes we like to put our engineering hat on pretty quickly and say, hey, I just want to start writing API calls and setting up a callback server. But sometimes taking the time, like, no, let me just make sure I know the state of my data and I know where it is at and what is happening with it. That can maybe be more valuable from a project standpoint than just writing the callback server or kind of getting into the code right away, as fun as it is. So
Exactly.
Well, terrific. I wanted to go ahead and pause there. We got about 10 minutes left. If anybody had some questions that, this conversation has inspired, this is the time to ask. We'll hang out for a few minutes here. And otherwise, Bolin, we so appreciate your time and sharing your insights with us. Really kind of value the partnership we've had so far and excited to kind of keep learning with you over the next couple of years. So thank you.
Sure. Yeah, it's really nice to be here today, and it's been a fantastic journey working together with Scale.
Yeah, awesome. All righty. And yes, there's also the link to fill out a survey. Probably email that out as well afterwards. But if you had any thoughts about how this conversation went, we'd love to hear them. So someone asks, how big should ML ops teams be? How many people do you kind of need to do ML ops, quote unquote?
I guess it really kind of depends on what kind of product you're aiming for. And if you're aiming at a smaller product, maybe you would just want to do, let's say, maybe a small app on your phone. Or if you wanted to do more heavy works with your, say here, with a self-driving car, then in that case you will need more people surrounding the MLOps. But I would say the really, the machine learning or deep learning parts of the MLOps is really just a tiny part of that. You have a lot of work to do with getting the data ready, so you have a lot of work to making sure that you can deploy that a good ML or a machine learning, or sorry, a deep learning model, let's say, to your product. So you would definitely need quite some skilled people to do those works for you. Yeah, but of course, how you organize your teams, that would be a different question. Maybe you wanted to keep them small and flexible and agile, let's say.
Bolin, do you think there's a ratio maybe of kind of ML research and scientist to an ML ops kind of counterpart, kind of working to make sure that the data, is how it needs to be and kind of working on setting up the broader infrastructure that supports the ML initiatives?
Yeah, I mean, looking back at our organization, I would say the dedicated, say, ML scientist is really rare. So most people needs to build engineering work from time to time. And of course, you're needed if you wanted to develop something fancy, something new, follow up, of course, with the state of the art. So all of these things needs to be done. But I would say the majority of the work are actually, making a neural network into a production environment. That is quite a lot of work to do.
Yeah, yeah. No, that makes sense. Alrighty. Well, thank you everybody for spending your Tuesday morning with us. Much appreciated. And again, if you have any other questions or follow up, please do get in touch, and you should be getting a recording of this presentation shortly. So thanks everybody. Thank you, Bolin.
Thank you. Bye.
Bye.